you might say, why do we law of cosines? We don't have law of sines.
There's not one of these.
Well, let's find out. I've got a triangle here, 3 pieces of information, and we want to totally solve this triangle. We'll find out tomorrow and Thursday what all this stuff is good for as we apply all of our knowledge of law of sines and law of cosines to problems that have boats and planes and distances and areas, all those things associated with them, okay? So right now, just let it be known that we have a little bit of information on a triangle. We want to find out the rest of it without having to go out and measure all of that stuff. So let's go ahead and fill out this triangle here, shall we? Angle A is 117. Side B is 47. And side C is 22. Figure's not to scale. That's pretty obvious because that's no way that's a 170-degree angle. But anyway, solve the triangle. So solve for angle B, solve for angle C, and solve for little a. Okay. Now, don't write this next step down here because this is a bad step. But there's a saying, when all you have is a hammer, everything looks like a nail, right? You just want to hammer it because that's the only tool you've got. Right now, the only tool that we have for solving triangles like this is the law of sines. So let's go ahead and hammer away at the law of sines at this problem, shall we? Once again, don't write this step down. Sine of 117 over little a, don't know what that is, equals, call out to me, class.
C.
Sine of B, or which one?
C.
Okay, C. Sine of C over 22. What's the problem with this?
There's
two unknowns. Yeah, I don't know what this is, and I don't know what this is. So I'm never going to be able to work this down to get an actual number for an answer. Okay? If you have one equation, you can only have one unknown. And we have an unknown here and an unknown here. So this makes us sad. We can't solve our triangle. Okay? Doesn't mean that that triangle doesn't exist. It just means that our tool here is the wrong tool for this set of 3 pieces of information. Speaking of which, let's go ahead and look at the information that is given to us. What sort of a triangle did I give you here? What sort of 3 pieces of information did I give you? A side, angle, side situation. I don't know if anybody was paying attention last week to this particular fact, but I never gave you a side, angle, side when we were doing the law of sines. It was always like an angle, side, angle, or a side, angle, angle, that's all kind of the same. Or the angle, side, side, and we did it with the ambiguous case, okay? Never dealt with a side, angle, side situation, okay? But now we will today. We wrote down that there's only one triangle that can be formed from a side, angle, side situation, but we never actually solved a triangle that was a side, angle, side, okay? So, let's go ahead and do that right now. So, on your theory notes here, law of cosines, we're going to draw everyone's favorite scaling triangle. And across from angle A, all the way out little a, across from B, little b, across from C, little c. Height h. And as a special little bonus treat, we're going to call this segment right here from angle C to the point of intersection of H and VC, we'll call that segment X. And then, since the whole length here is A, and this section right here is X, then that means whatever left over must be A minus X. Alright, so what we're going to do now is we're going to step-by-step figure out what this law of cosines is, okay? How we actually use it is going to look different, but, so here we go. I'm going to start off by focusing in on this left-right triangle. I said that correctly, actually. Left-right triangle. So hypotenuse C squared, that equals a minus x squared plus h squared. Does that make sense? Sort of Pythagorean theorem here. Hypotenuse equals side squared plus side squared.
Is that in, what's on the bottom?
A. Does that look like an A to you? I mean, that's very clearly an A. Sorry about that. Alright, there we go. Alright, I know it's Monday, it's still morning, so I will give you the benefit of the doubt here and expand this a minus x squared to a minus x, a minus x, and then we'll FOIL it all out there.
Wouldn't one of them be a plus x?
Nope, because it's just a minus x quantity squared. So that
Okay.
means a minus x times a minus x. There is a situation where you have a minus b and a plus b, but that's, you have to, that's when you have the difference of two squares, a squared minus b squared. This is a minus x quantity squared.
Okay, so whatever's in the parentheses, that's squared.
So this would be a times a, which is a squared, a times negative x, which is negative ax, negative x times a, which is negative ax, negative x times x, which is x squared. And I don't know why I'm writing this, because y'all are honors pre-calculus. And you should know that if you have blah minus blee squared, that's blah squared minus 2 blah blee plus blee squared. Y'all remember that?
Yes, those exact words, I remember exactly.
A minus b quantity squared is a squared minus 2ab plus b
If I
squared.
find my notes from last year, I have blee squared.
Well, I can't call them both blah.
Disconnection every second.
Alright. Side note, over here, I'm going to look at this right triangle and do Pythagorean theorem on that one. So b squared, the hypotenuse, equals x squared plus h squared. Haley, would you agree with that statement? This is Pythagorean theorem for this right triangle. X squared plus h squared equals b squared.
Yes.
Make sense? Okay. And I just write that because notice x squared plus h squared, x squared plus h squared.
Oh,
I shall perform a substitution. C squared equals a squared minus 2ax plus b squared. But I don't like this b squared all by itself on the end there. I want it to be alphabetized here, so I shall write c squared equals a squared plus b squared minus 2ax. Alright. Now, another side note, still looking on this right triangle, I'm going to write cosine of angle C. So class, remind me, cosine of an angle is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. In this case, the adjacent angle C is, looking at that right triangle. Adjacent to angle C, anybody? X. X over what?
8?
Nope, not x over h, because the hypotenuse is right here. So it's x over b.
Oh, I thought hypotenuse.
Then we'll multiply both sides by b, and we get x equals b times the cosine of c. And I'll substitute that in for that value of x right there. So my final answer here, c squared equals a squared plus b squared minus 2ab cosine c. And that, my friends, is the law of cosines.
Oh my gosh.
That formula right there.
Love that.
square of a side is equal to the sum of the squares of the other two sides minus 2 times their product and the cosine of the included angle.
Yes.
Should I say that again for you?
No.
You're going to say it here in a minute.
Oh.
Alrighty.
So, let's draw this picture one more time, but without all the gobbledygook on it here. A, B, C. Across from A, little a, across from B, across from C, little c. So in this situation, c squared, or little c is what I don't know. And this is a case where I give you an angle, or sorry, a side rather, a side, and an angle in between them. So c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle c. So I'm going to go through and we're going to label what each part is here. So little c is the side that you don't know. Okay? So we can say, I'll just write the square of a side equals the sum of the squares of the other two sides. Sum of the squares of the other two sides. I could say of the given sides, but I'm just going to say the other two sides. Minus 2 times, and then again, notice we have A and B again. It's the same thing as we have here. And I'll say, when we multiply with, we're saying the product of those sides and notice cosine of angle C. Angle C is immediately in between them. I could say this is the given angle, although in math terminology we normally say the included angle because it's the angle that's included between those two. And the cosine of the included angle. So altogether we would say the square of a side is equal to the sum of the squares of the other two sides minus 2 times the product of those sides and the cosine of the included angle. So repeat after me, class. The square of a side
Square of a side
is equal to
is equal to
the sum of the squares of the other two sides.
the sum of the squares of the other two sides
Okay, here, John. Minus
minus
2 times
2 times
the product of those sides
the product of those sides
and
and
the cosine of the included angle.
the cosine of the included
A little bit louder there next, so here we go. The square of a side, the square of a side equals
The square of the side equals
the sum of the squares of the other two sides
the sum of the squares of the other two sides
minus 2 times the product of those sides and the cosine of the included angle.
minus 2 times the product of those sides and the cosine of the included angle.
Alright, see? Making more sense now?
Kind of sort of how it works.
I bet if I draw one picture over your hand, I bet you're gonna get it first time. Okay?
That's how
So goodness.
I totally, alright, so D, E, F.
What?
Yep, I got it.
Little e, little f.
Very fast. Lee.
Okay? So I'm going to give you this side and this side and that angle. And we're going to write down the law of cosines. Okay? So I'm giving you this one, and this one, and we don't know that one. I'll get you started. F squared equals, take it away, Hannah.
Oh dear. AB squared plus B squared
Keep going.
minus 2 times E times D times cosine F.
There we go.
Good job, Hannah.
Good job. See, I knew you could do it. Do y'all see how that worked?
Yes.
There's a side that you didn't know is equal to the square, sum of the squares of the other two sides, minus 2 times those guys, times the cosine angle between them. Let's go back to that practice worksheet now.
Is that the answer?
That's the formula.
You have to plug in all the numbers.
Yeah, plug the numbers in, yeah. I mean, that's... Okay. So looking at this one, okay, what is the side that I don't know, class? A. So I'm gonna write A squared equals, now someone other than Hannah. Say it to me in terms of A's, B's, and C's, because I want to make sure we all get the formula down correctly. So A squared equals, anybody?
C squared plus B
C squared plus B
squared
squared, keep going.
minus 2 BC
2 times B times C, yep.
times cosine
Yep. Cosine, oh, sorry, I put 117. Cosine of angle A, there you go. That's applying the pre-calculus knowledge. Now you just apply algebra knowledge of how to plug in numbers.
Smarkles.
So A squared equals 22 squared plus 47 squared minus 2 times 22 times 47 times the cosine of 117.
Well, I like that.
I know, it's not too bad.
That's not bad.
Then, in order to undo the square, you just take the square root of that whole thing. Just type in 22 squared plus 47 squared minus 2 times 22 times 47 times cosine 117. Make sure you're in degree mode. You'll get a number for all of that, and then you just take the square root of it.
Oh, yay. Okay. Okay.
And I await your calculator's answer. It's sort of a joke. I think it was something like a Simpsons episode or something like that. They said, all right, now whose calculator has the right answer? It's sort of like, ouch. Anybody have a value for A? I think it's somewhere in the 60s.
I just cleared it.
I'm hearing 60.3. Anybody else get that?
Hang on, where's that done?
Oh, yeah. I forgot to do it.
Oh, really?
Alright, now the official answer, I mean, what we're going to type in on Alex is 60.3, but y'all's calculator has really like 60 point, blah, 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 all that stuff like that, right? When we do subsequent calculations, okay, well, they tell you, carry your intermediate computations to at least 4 decimal places. So, that, just call them out to me, Hannah. 60 point.
264.
264.
You rounded to 9.
Okay.
You can truncate at this point right here. You can truncate or round. It's not going to matter as long as you're giving those first 4 digits. I would just truncate. Just give those 4. Okay. If you're using one of the blue calculators, you can normally hit the up arrow to use a previous value. Okay. Or you can hit the shift answer button. Do y'all know what I'm referring to? Shift answer.
The second negative sign.
Yeah, that'll work as well. Okay, so we found that first period that was kind of problematic, but that's because we didn't read the instructions that said you have to carry your intermediate values before. All right, so we still have not yet fully solved this triangle. We need to figure out what is angle B and what is angle C. So what tool shall we use now to find, say, angle B?
Law of sine.
I like law of sines. We can say sine of b over little b, which is 47, equals sine of 117. And this is where your intermediate calculations, if you could write on your paper, you could put 60.3 or you could write 60.2648. Whatever you do, and your calculator uses as many digits, as much precision as possible. 60.2648. So we should be experts at law of sines now. We're going to multiply both sides by 47, do the division, and then do the inverse sign in order to figure out what angle B is. Right? 47 times sine 117 divided by 60.2648. Inverse sign. And we have a number on that? Something in the 40s?
44.01.
Okay. And to the nearest tenth, that's going to be 44.0. So now we have one calculated value, and then this 117. We should be able just to add those two together. 44 plus 117. Subtract that answer from 180. And you get angle C equals 19, or 19.0. There we go. We've solved the triangle. We've used the law of cosines. Some people say, let's use the law of cosines first. The problem is that really to solve these type of situations, you have to end up using the law of sines anyway, later on down the road here. Okay, what I want you to do is, as a table, I want you to work, skip number 2 and go to number 3, okay? Skip number 2, go to number 3. I'm going to take attendance and I'll walk around and see if you have any questions on this.
So you write equative sign and equals this, right? And so you just want to solve for A, so you multiply
Yeah,
on the bottom.
yeah,
and this sign.
You were
And then you plug in
Yeah.
sin of 85, divide that by base. And then times by this, and then you have, and that'll equal sine A. But then to get what A is, you do the inverse sign. On the calculator, you know, you do inverse sign of whatever you got.
Okay.
Make sense? So you get why I'm referring to that. Yes, because I canceled that when you multiply it, so I multiplied over here. So now see from here, I just wrote the sine 85 over the 29.13 divided. Yes, and then the whole thing times 49. And I just wrote the calculator. And so I do sine 85. And I hit enter. Yes, I did. And I enter. And then I just divide. I'm gonna do one. No. Not 49.1, just 49. Because 49 is the step they gave us. Okay, so
Go again.
once you get. Then you do this. You do the second.
Okay, so you do sine C
Of your answer. And
over
that's-
10, yep, equals sine 85. Yeah, that looks good. Let's keep going. Do they match? Nice and operate. Round it.
It's
And there's 10, whenever y'all finish.
Yeah.
You get there?
Yeah.
5, 8, 3, 4, 3. And then you can find the other one,
Yeah.
right?
Yeah.
And y'all good? And that would, yep, and that would tell you what number to use that. It is, yeah. 0.20269, right?
Oh, and then you have to do the end where you add.
Inverse sign, yeah. Do inverse sign of that answer.
What did you do this for?
0.20269.
Okay, so, okay.
This?
Is that right?
Side B done. Well,
What's up? There we go. Did you get him? Okay. All right. Walk around. Looks like pretty much everybody got this, or you got far enough down here to that I'm pretty satisfied. Sorry, that was number 3, I guess. But all right, let us look at number 2, because I'm going to throw the proverbial wrench into the works, into the
Oh,
machinery.
great.
Okay.
I just understood, I was gonna do that myself.
All right. Well, you still I'm not going to take away. You completely understand that type of problem. I'm just going to give you a new type of problem. So here we go. So A is 55, B is 26, and C is 65. Uh-oh. What type of triangle is this?
Side.
It's a side-side-side triangle.
Brother.
Now, you remember we tried this with like the pencils and the pens and the paper clips. Side is how many triangles? None or one. One or none. We'll assume that this is not a none situation because I'm not going to give you weird numbers like that. So there it is. It's not the scale, but that is a nice triangle. Okay. Let's think about law of sines on this one first, shall we?
Sure, why not?
So I'll say the sine of angle A over 55 equals sine of B 26. Does anybody like that or not like that?
I don't think
Why not?
we have two unknowns.
We have two unknowns. We don't know A and we don't know B. Law of signs is out on a side, side, side situation. Well, let's think about this. Do we have, with law of cosines, do we have side C?
Yeah.
Do we have side A?
Yes.
Do we have side B?
Yes.
Do we have a 2?
Yes, it's there.
Do we have side A?
Yeah.
Do we have side B?
Yes.
The only thing we're missing,
Oh.
Manipulation.
we are. Math is never satisfied. As soon as they give you a formula and you know how to use it, then we just need to change it all around to solve for the other part. So let's go ahead and change this formula around one time, okay, algebraically, then we won't have to plug it in and mess with it all the other times. So let's go ahead and manipulate this formula so that this C is all by itself, or the cosine C. Alright, so maybe back on your formula paper there, I'm going to subtract A squared and I'm going to subtract B squared from both sides. So C squared minus A squared minus B squared equals negative 2AB cosine C.
Well, then you just
I don't really like that negative 2 there. So I'm going to multiply this by a negative 1. And I'm going to multiply this side over here by a negative 1. Now that negative 1 will get distributed. So that negative A squared becomes a positive A squared. Negative B squared becomes a positive B squared. And that becomes a negative C squared. 2AB cosine C. Yeah, I'm going to divide both sides by 2AB.
And then a final formula?
I like this version of it. Yep, cosine C. So the cosine of any angle is equal to the other two sides squared minus the side that is across from this particular angle, divided by 2 times the product of those other two sides. So here's a nice generic, John, that way you don't have to deal with all the numbers. You know what I'm saying? I think this is easier than plugging the numbers out, but that's just me. Anyway, I like this, but there is one catch to it. You need to start with the smallest angle. Otherwise, you might end up with an obtuse angle, you take the inverse cosine, and you get something kind of weird. All right?
What do you mean start with the smallest? So
Start with the
angle
smallest.
A would be the smallest thing?
Is angle A the smallest side, or the
No.
smallest angle in this case?
Angle B,
How do you know that angle B is the smallest angle?
because little b is the smallest.
Because little b is the smallest side. That's right. So as soon as I know that formula, now I'm going to rewrite that formula in terms of B. I'll say cosine of angle B
Okay.
is equal to, now I'm not going to write A squared plus B squared because that's not the proper terminology. These guys, A squared and B squared, are the other two guys. So if it's C, then it's A and B. If it's B, then this is going to be A squared plus C squared. Y'all see where I'm coming from with this? These first two guys squared are the other sides that aren't matching this one. Then I have minus the side who's across from him, divided by 2, and then times these guys. So 2 times A times C. So cosine of angle B, just plug in the numbers now. 55 squared plus 65 squared minus 26 squared divided by 2 times 55 times 65. I'll give you a heads up, third period students, we're not doing the entire numerator divided by the entire denominator. They were doing like 55 plus 55 squared plus 65 squared minus 26 squared divided by, and just putting just the regular divided by thing, and then all of this stuff down here, and it was just dividing the 26 squared. It's a weird answer. So do the whole numerator, enter, divide by, and then put the whole denominator in parentheses is one way of doing that. that should give you a decimal answer. How shall we get angle B then? Inverse cosine, that's right. And when you do the inverse cosine, that's the part where if we had an obtuse angle and we did the inverse cosine, we would get a negative answer. And we don't want that. It might give us it might work actually. Yeah. It's just easier to pick the smallest one.
Oh, I didn't use there.
Let me know when y'all get an answer. So that's gonna be 23.2. Alright?
There we go. What? Yeah.
Alright? And then we're gonna pick the next smallest side. We could do law of cosines again if we wanted to, or preferably, I don't know about y'all, but I do like the law of sines a little bit better. So I'm going to pick the small side just because that's sort of a good procedure here. So I'll say sine A over 55 equals sine. Use full precision here. Okay. So sine of the 23 point blah 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 blah. Divided by 26. Use full precision there. Let me know when y'all get an angle or an answer for angle A. I hear 56.3. Is there agreement?
Yes.
Now, this is something that y'all need to pay attention to. This will mess you up. This is somewhat of an easy topic to get on Alex once you kind of get in the groove on this one, okay? But I want to tell y'all something. Let us figure out angle C the easy way. 23.2 plus 56.3, answer, subtract that from 180. And what do you get? 100 point what? 100.5. And that's the wrong answer.
Yes.
You're close. You're really, really close. All right. Look at the book. Look at the book. Look at the answer sheet. 100.6. What?
Because of the decimal.
Yeah, it's because of the decimals. It's because what we're doing is you're taking a rounded answer here to the nearest tenth and a rounded answer here to the nearest tenth, okay? And you're coming up with another wrong answer, okay? They said carry all intermediate computations. So what you could do is you could use this to 4 digits and this to 4 digits, or you could just do law of sines again, okay? If you do law of sines again, you will get 100.6, okay? Now that's going to lead to some issues like, hey, wait a second. If I add up all 3 of those angles now, I'm going to get 180.1 degrees, okay? And you might say that's a problem. And I would say, yeah, that is a problem, but it's not an unknown problem, or it's not a problem of unknown origin. We know exactly why we get 180.1. It's because we rounded this one, and when we rounded it, we bumped it up just enough, okay? That it's almost a tenth, but not quite. And we rounded this one, we rounded it up, and it was just a little more than almost a little more than half a tenth. Okay, and so those 2 errors combined is going to create
Another error.
yeah. So anyway, so that's this is the better answer right here, the 100.6. Okay. Unfortunately, we don't have enough time to do another side to that side, but if those good notes, I think you're good. Class, talk to me. What did we discuss today? All right, all of you that just said something, that's great. Somebody else, give me more details. What did we use the law of cosines to do? solve a side angle side triangle. Also, a side triangle. And we are now fully equipped to tomorrow to apply this situation with boats and planes and trains and automobiles. Alright, thanks for watching. See you tomorrow.